In this video, we will look at using SunCast within the IESVE to optimize the placement of PV panels. We'll start with a simple office model created within Modelit. If we look at the roof, we can see a number of PV panels which we have placed for our solar analysis. Now we can move on to perform solar calculations using SunCast. SunCast can be used at any stage of the design process to perform solar shading studies or solar exposure analysis, and can generate images and animations easily from a VE model. The shadows and internal solar insolation are calculated from any sun position, which is defined by date, time, orientation, site latitude and longitude. Within SunCast we have three tabs: Model, Images and Analysis. The Model tab shows the model browser and viewport of the model, and the Images tab is used to generate shading images. We're going to use the Analysis tab for visual analysis of solar energy and exposure on our building. Here we can calculate solar energy or solar exposure using these buttons. It doesn't matter which we pick when we run our analysis, it just determines which format we view the data in. We can use either after running a simulation. Our location has already been defined when we set the weather. SunCast calculation will use this to define our building's position. Here we choose our desired simulation period. This can be a full year, a single month, a single day, or a specific date range. We'll leave this as annual. The next option determines if the simulation will consider diffuse shading factors. Diffuse radiation is a significant component of solar energy calculations that will help accurately model the performance of PV panels. However, it will increase our simulation time. We'll tick this box for today's example. Then we'll choose to get a more detailed analysis and visual result by slicing up our building's facade into square grid cells from 0.1 to 10 meters. The smaller the grid cells, the more detailed the analysis. Again, this will increase our simulation time. We'll tick this and define a grid at 1 meter on the building. We click the Simulate button to start. A task window will open showing the progress. Once it is complete, we can click Load Results here and close the task window. We choose whether to display energy values in kilowatt hours per meter squared or kilowatt hours. This threshold option allows us to filter results by only applying colour to surfaces that have values above or below a certain threshold, or within or outside a certain range. This could be used to identify hot or cold spots on the facade of our building. We've also got different colour gradient options for visualising our solar analysis. We'll leave everything as defaults and hit Apply to overlay our results onto the model within the model viewer. This will include a legend for the results for easy visual analysis. To show solar exposure values instead, we just click on this button and choose between exposure hours or exposure percentage. We'll go for exposure percentage and apply. This is an extremely useful tool when considering where it's best to add PV panels to the building for reducing our carbon footprint. We can see the PV panels have been placed on the roof area where the orientation maximises solar exposure for this building and location. Once we've run the simulation, we can save the analysis results for later investigation with a clearly named zip file. SunCast can be ticked on as an option when running full dynamic simulations in Apache to incorporate the impact of solar shading in design assessments to maximise daylight and minimise energy consumption. In this video, we looked at when to use SunCast in the VE to optimise the placement of PV panels. For further hints and tips, please check out our other tech tip videos. Thanks for watching.